Good morning, everyone. Today is Monday, April 17th. We are behind schedule. So today we'll talk about session 5.3. And you have homework 8 and quiz 5 due today. And homework 8 and quiz 5, they're about section 4.1 and section 5.1. So section 4.1 is about rational functions, right? We talk about vertical asymptotes and horizontal asymptotes. And then you need to know how to graph the rational functions. And then remember all the steps, right? So yeah, so review your notes about section 4.1. And then 5.1 is about exponential function. Okay, so review that. And this Friday, we will have homework 9 and quiz 6. Look at our schedule. You're gonna be very busy the remaining weeks. So I sent some of you, okay, if you made some previous homework, practice exams, exam correction and wrapper, you received my email, okay? So how do you check what assignment that you missed? So you go to your Blackboard and then you go to My Grade, then you can see all the homework assignments, okay? So if you get 10 points, that's good. If you don't get 10 points, if you miss some points, maybe you miss something. Maybe you forget to use red pen to correct your work, okay? For the exam correction and wrapper, some of you only submit the exam wrapper. That's why you may only get 5 points out of 10 points. So if you don't get 10 points, there is a reason. Figure out why. And then you can resubmit to gain those points back. Okay? So homework and self-assessment, I hope all of you can get perfect scores. Because you are able to get perfect scores if you submit the work. Okay, everybody? I hope those can help you to move up your grades. Yes. All right. So, any questions? So, for those of you didn't miss some work, please submit those as soon as possible because you're gonna be very busy the remaining 3 weeks. No, we only have 3 weeks, and then the final exam. By the way, exam 3 and final exam. I'm gonna change the format about the review session. So here are the review session recordings from my previous semester. So what you're gonna do is we won't have an online review session together. You're gonna watch the recording. You can pause at every step to think through the math, or you can watch it anytime. My recommendation is please watch it like 1 week before the exam. Okay, so do the practice exams. After you finish, watch the video session recording and use red pen to check your answers. Is that clear, everybody? And then if you have questions, come to see me. Okay, so come to my office hours, or you can email me, you can meet me virtually. Okay, everybody? So we have video session recordings, and come to ask me if you have more questions. Okay, so that is our plan. Okay, so 5.3. Okay. Properties of log. So last time we know that exponential function and logarithmic functions, they are inverse functions, right, everybody? And so we need to know the following logarithmic rules like your own name. Okay, so properties of log. Assuming P and Q are positive, and then the following holds. So log B of PQ equals log B of P plus log B of Q. So log break the product inside the log into sum outside the log. This is what it means. Okay, but why? So this is the proof. Let's call X to be log B of PQ. Let's call A to be log B of P. Let's call C to be log B of Q. And you know, log and exponential functions, they are inverse functions, right? So this is the log form. X equals log B of PQ. Then what is the exponential form? Well, our base is B. And then my X, well, here is my output, and here you put it in the input. Right, everybody? And the PQ was in the input, and then you put it in the output. So this is the log form, and this is the exponential form. You get B to the X equals PQ. That's huge. Is that okay, everybody? And A equals log B of P. Base is B. And A, now it was the output, now you put it in the input. The P, it was the input, you put it in the output. So this means B to the A equals P. Is that okay, everybody? Similarly, log B of Q equals C, it means B to the C equals Q. Is that okay, everybody? Now, B to the X is P times Q, but P is B times A, and Q is B times C. Now, because the exponents rule, if we have the same base, we can combine those two factors, and we just add the exponents. Right, everybody? We add the exponents. Therefore, look at both sides. We have the same base, and then we can set the exponents equal to each other. Right, everybody? If we have two expressions, we have the same base, then we can set the exponent equal to each other. Therefore, we get X equals A plus C. And what was X? X was log B of PQ. And A plus C, so log B of P plus log B of Q. So this is the proof. So after you transform to the exponential forms, and then you can see why it works. Okay? But from now on, you don't need to memorize the proof. Just remember log, break the products into sum outside the log. Okay, everybody? How about quotient? Oh, this is Q. Okay? So if you call this By, it means B to the Y is P over Q. And then by the exponent rule, B to the A over B to the C is B to the, what happened to the exponent? You subtract. Right, everybody? So therefore, Y equals A minus C. So that means log, break the quotient inside the log into subtraction outside the log. Is that clear, everybody? Okay, so log break the product into sum. Log break the quotient into subtraction outside the log. Okay? How about the third rule? Okay, let's call this to be Z. So Z is log B P to the N. Ooh, that means B to the Z equals P to the N. But what's P? Well, P is B to the A, right? And then B to the A to the N by exponent rule is B to the A times N. Right, everybody? And then we compare the left-hand side and the right-hand side. Because they have the same base, we set the exponents equal to each other. Therefore, we get C equals A times N. And C is the left-hand side, and then this right-hand side is A times N. So this means whenever you have an exponent on the inside the log, you can move that exponent down in front, become a coefficient. Is that clear, everybody? So this is the proof. Okay, in the exam, you don't need to memorize the proof. Just remember the log property, three properties. Log break the products into sum outside the log. Questions?
For the B or for the Pn,
Yes.
B to the N equals B to the A
To the N?
Yeah.
Yes.
Is that supposed to be a fraction with P underneath it, or what was
Oh no, this is P. P is B to the A.
Oh, okay.
Yeah, p is b to the a. That's why you replace p by b to the a. Yeah, so this is p, okay? And then, oh, because of the exponent rule, b to the a to the n is b to the a times n. Yes. So whenever you see some exponent inside the log, you can move that exponent outside, down in front. So that is the rule. Is that clear, everybody? Mm-hmm. Oh, attendance. So for those of you coming late, please go to Blackboard and click my grade and see what assignment you missed, okay? And submit those as soon as possible. Today you have homework 8 and quiz 5. It's section 4.1 and 5.1. This Friday you have homework 9 and quiz 6 about 5.2 and 5.3. You're gonna be very busy the remaining 3 weeks. Okay? That's why I keep sending you email, turning your assignments. Yes. Okay. Oh, and then continue. Okay, so we have talked about the properties. Now let's do examples. So there are two type of problems about like this topic that I will ask you. Okay, one is to condense. Okay. One is to condense the following expression into a single log with a coefficient of 1. Simplify further if possible. So here we have two log expressions. You want to combine into a single log. Okay, so this is one type of question that I will ask you. And what do you do it? Okay, so here are the steps. So step 1, you're gonna move all coefficients to the exponents inside the log. And then 2, you're gonna combine. Okay? You combine, so that means if you see the sum, you make it into a product inside the log. When you see a subtraction, make it to be a quotient inside the log. This is so important. Inside or outside is so important because we all know that sum is not multiplication, right? And subtraction is not quotient, right, everybody? But this tells us that the sum outside the log, when you combine them, you get a product inside the log. So be careful. We're not saying this is log b of p times log b of q. No. Addition is not multiplication. Right? This is true only if the product and multiplication is inside the log. Is that clear, everybody? And here, subtraction is not division. So this is not log b p over log b q. No, subtraction is not division. Okay? It changes to be a quotient inside the log. Only if it's inside the log, then this is true. Is that okay, everybody? Yes. A common mistake is students get confused about subtraction and division. You know that they're not the same, right? So this is the law of rule. Inside or outside, very important. Log of a product inside, you can break it into a sum outside the log. Okay? And the log of a quotient inside, you can break it into a subtraction outside the log. Inside and outside, very, very important. Is that clear, everybody? Okay, so first step, move all the coefficients to the exponent. So see, if you have a coefficient here, you want to move it to the exponent of the input. So therefore, what do you move this to here, right? So we move this to here. So we got log base 6, and this is 2 squared. Right, everybody? And then the next one, okay, the coefficient is 1. No, we don't need to do anything. Alright, so this is the first step. Move all coefficients to the exponent inside the log. And step 2, combine. Do you have a sum or difference? It's a sum. What do you do? Log 6. 2 squared times 9. Right, everybody? And do you know what is 2 squared? 4. 4 times 9? 36. Oh, what is 36? Do you see the base is 6? What's 36 related to 6? 6. 36 is 6 square. Yeah. Oh, what is this? 2. Remember log 6 and exponential function? They are inverse function. The log 6 of 6 squared, you cancel, you just get the 2. So if you missed some lecture, make sure you watch the lecture videos. And then if you have questions on the notes, come to see me, okay? So today I didn't bring the sheets, but you know my office hours are, right? So Tuesday, Thursday, I have a lot of office hours. So come to ask me questions. Okay. So Wednesday, I will give you a sheet to sign your name. All right. But if you have questions today and tomorrow, yeah, feel free to come ask me. All right, so let's keep going. Part B, I will let you do at home. So part C, let's make the problem harder. So let's put a 5 in front of it. So you get 5 log 4x minus 3 minus 2 log x. So what do we do? First, we move the coefficient to the exponents. By the way, if you see log, if you don't see a base, that means the base is 1? 10. Yes, log means base 10. Ln means base ln, natural log. Base is yi. Okay, log means base 10. Ln means base yi. Okay, so we can move the 5 to the exponents. Is that okay, everybody? You move the 5 of the, by the way, you need a parentheses. You cannot just move the 5 on top of the 3. It's the whole thing. Is that clear, everybody? It's the whole thing. So you need a parentheses. And then subtract 2, you move up there, you get log of x squared. Right? Everybody? So 2 steps. Step 1, move all the coefficients to the exponent of the whatever inside the log. Okay? And don't forget parentheses. And second step, combine. What do you get? Yes. So combine the subtraction into a quotient inside the log. Okay? Because you want to get a single log. See, this is not a single log. This, after we combine, is a single log. It's a log of some expressions inside the log. So this is a single log. So the problem wants us to condense all the following expressions into a single law.
Why make negative log x squared be the denominator?
Oh, because that is the rule. Here, you have subtraction, then it becomes the quotient inside. And why do we do that? The proof is right here. Because it's b to the a and b to the c, and then what do you do to the exponent? You subtract. Yeah, that's why quotient corresponds to the subtraction inside the exponent. Is that okay, everybody? Mm-hmm. All right. So these are the two steps. Okay, part D. Part D. Do you see we have a bracket there? That's the answer, because it's a single law. We're done. After we get a single law, that's done. That's how it goes. Condense the law expression into a single law with the coefficient as well. Okay, here. Do you see a bracket here? So we can figure out what's inside here, and then we can take care of the two later. So it's 2 times, look at this, the first term, the coefficient is what? 1, right? So it's okay. Then here, what happened to the 3? Yeah, move inside. So move to the ln of x plus 2 cube. Is that okay, everybody? Yes? So move inside x plus 2, parentheses, cube. How about the 4? Also move it inside. So x plus 3 to the 4. So that is the first step. Move all the coefficients inside and become the exponents. Is that okay, everybody? Next. Okay, if you have more than 2 terms, you just look at the sign in front of it. If it's nothing, it means the sign in front of it is positive. If the sign in front of it is positive, that means when you combine them, that factor is in the numerator. If the sign in front of it is negative, that means that factor is going to be in the denominator. Is that clear, everybody? Mm-hmm. Yes. So no matter how many terms you have, you can have 5, 6 terms. And then for each term, if the sign in front of it is positive, you put that in the numerator. If the sign in front of it is negative, you put it inside the denominator. Okay, everybody? So if the sign in front is positive, move that in the numerator. And if the sign in front is negative, move that in the denominator. Okay, so therefore, we have 2 times ln of, where do you put the x minus 1? Top or bottom? Top. Where do you put the x plus 2 cube? Bottom. And where do you put the x plus 3 to the 4th? Bottom. Right, everybody? Okay, so this is a single law, but the coefficient is not 1. Yes, everybody? It's a single law, but the coefficient is not 1. How do you get rid of that coefficient? You can move inside. So move that inside here. You get ln of, you can have like everything square, or you can like distribute the square. So when you distribute the square, all the factor, and you multiply by 2 on the exponents. Is that okay, everybody? Yes. You can distribute the square, right? if you have a over b to the n is a to the n times b to the n. When you have a product or division, you can distribute exponents. So you have x plus 2 to the what? Huh? What number? 4? 6. Yes. X plus 3 to the 8. Because you have the square here, and when you distribute each exponent, you square it. That means you multiply the exponent by 2. Is that okay, everybody? Mm-hmm. All right. So keep going. That's why when you take notes, try to write out what you're doing. And when you have a new problem, you can follow the steps and do the new problems. Okay, so that is one type of problem. The other type of problem is the opposite. You have a single law, and you need to expand it. Okay, everybody? Expand it. You want to express as a sum and differences of simpler log functions. And you also have the coefficients. So here, look at it from the outside to the inside. Do you see the 3 here? So we can move the 3 outside. Okay? So move the 3 outside. We got 3 times log of x minus 1, x plus 2. Right, everybody? So here we're doing the reverse direction. We want to expand it. Last one, we want to condense into single log. Now we have single log. We want to expand it. So move the 3 in front. Log. When you see quotient, what happens? Subtraction. So it is subtraction outside the log. Okay, everybody? Yes, questions? That's wrong. Yes, because you want when you distribute it, you have 3 here and you have a 3 here. It's like here. This is a division, right? You can also distribute the 3 here and there. So if you read without a bracket, it will be wrong. Or you can distribute the 3. You get 3 log x minus 1 minus 3 log x plus 2. So both of them are correct. Okay, good questions. Okay, how about part B? Now you do part B. Part B. Four roots corresponds to 1 over 4. It's 4 roots. It's not 4 times. It's not 4 times squared. It's 4 roots. 4 roots is 1/4. Okay, everybody? 4 roots. 1/4. Yes. Yes. And then you don't have to square roots. It's not square roots. It's 4 roots. After you use the 1/4. Oh no, they're all inside. So when you see a product, you break it into some, and you see a portion, you break it into fraction. Yes, good. Yes, good. 4 roots, wait, it's like the power 1/4.
Square root.
Yes, and then you have a parenthesis here, right? You can break this too. You can break it to some. which is ln of x plus ln of x plus 1. It's a product. You can break it into a sum.
So this gives like 4.
Yes, this one. Yes. This is a product. You can break it into a sum. Don't distribute it. Our goal is to break it. And don't distribute. You see it's the products. You put the product into sum, and you break the quotient into a subtraction. Okay, so this is 4 roots. It corresponds to the power 1 over 4. Oh, we're done. We're done with that one. Yeah. Oh, do you have the header? Oh. Okay. Oh, you wasn't here? Oh, I brought some coffee, but they.
So is this right now?
Plus.
Plus.
Yes. Break the product into sum.
Oh, okay.
Yes,
Yeah.
yes.
Okay.
Okay. All right, let's check our answers together. So, this is 4 roots. 4 root means is to the power of 1 over 4. Therefore, when you move the 1 over 4 in front, you get 1 over 4 times x plus 1 over x plus 2. Okay, now what happened? So this is corresponds to this, right? If you see a factor, we're doing the reverse. If you see a factor in the numerator, you're gonna, when you break it, the sign in front of it is plus. When you see the factor in the denominator, when you break it, the sign in front of it, you put a minus. So therefore, look at each factor. X is factor, right? Is it in the numerator or denominator? Numerator. Therefore, when you break it, you have a positive in front of the ln of x when you break it. But because it's the first term, you don't need to put a plus sign there, right? Okay, x plus 1 is on the numerator or denominator? Numerator. So when you put it down, do you put a plus or minus? Plus. Yes, numerator, you put a plus in front of it. How about x plus 2? Is in the denominator, so we put a negative in front of it. Okay, everybody? Good. So this is part B. Okay. Any questions about this 2 type of problems? So you either have a lot of law expressions you want to combine into a single law, or if you have a single law and the problem asks you to expand. Okay, so each term is a simple log and with only like one factor inside. Okay. Now, most calculator only handles base 10 and base E logarithms. But what if an application requires a different base? Here is what you need. So this is the change of base formula. Okay, and the proof is okay. So I can show you the proof. Okay, what's the proof? You call this to be P. Okay, and let's say you call this is Q and this is R. So log AX is P. Well, that means A to the P equals X. Is that okay, everybody? This is log form. This is exponential form. The base is A. Yes? Everybody? The base is A. And this means A to the P is X. How about this? It means what? B to the Q is X. Right, everybody? And how about the last one? Is B to the R is A. Right, everybody? Everybody? Okay. So let's see. Look at this. We see the A, right? Then we can replace A by B to the R. So here, A is B to the R, and then to the P is X. And here, by exponent rule, what do you do to the exponents? Do you add them or multiply them? B to the R to the P? Multiply them. So this is B to the R times P. On the other hand, we know X is B to the Q, right, everybody? Now, do you see here, this left-hand side and the right-hand side, we have the same base B? Yes? So the exponents, set them equal. We get R times P is Q. So R times P is Q. R times P is Q. Therefore, P, see, we want to show this formula. So P equals Q over R. So that's finished the proof. Okay. So what does that mean? Okay. Log AX. If we want to change to any base, so B is any base, any number, then it's the log B of X. You put the X on top over log B of A. You put the A, you can see here, looks like X is above the A, right? So when you put them here, your base is, you can change to any base, and then you still put the X on top and you put the A in the bottom. This is how I remember it. X is above A, right? Then you put the X on top and put the A in the bottom. Okay? And the base, you can change to any base. That's why usually we can change to the natural log. So if we change to the natural log, this is ln of X over ln of A. Because you can change to any base. If you let B to be E, then you get the natural log. Okay, everybody? So estimate this using your calculator. Round to the nearest thousands. All right. See? Let's use the natural log. Okay, what do you put on top? What's your X? Yeah, what do you put in the bottom? A, what's A? 13. Okay, good. Everybody take out your calculator. Put, yes?
Wouldn't log and then in parentheses 66.3 and then exponent would be 13? Would that not be the way to do that?
This 13?
Yeah, would that not be the way to do that?
No, not be the way, because you move to the exponent is when you have the coefficient, not the base, right? I know we're learning new rules here. It's very easy to use. So do more exercise. When you do more exercise, you get used to the rules and you know how to use it. Okay, so what do you get? 1.635. You all get the same answer? 1.635. So everybody take out your calculator. Show me what number you get. Yes, show me what number you get. So, good. 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 Get it? Yes, you?
I didn't use it on like.
Okay. And yeah, okay, good. Ah. Okay. So now, do you remember why we introduced log? Because we were trying to solve this, right? And here, 2 to the x equal to 7. So how do we solve for x? Now, when you see exponential function, apply ln on both sides. Then you get ln of 2 to the x equals ln of 7. So in order to be able to use your calculator, always apply ln. Don't apply other law. Okay, just apply ln. Now, do you see what happened? The x, it was in the exponent. Now you can move it in front. Everybody look at me. This is so important. We want to solve for x. So if you have exponential function, isolate the exponential term. Then apply ln. Okay, don't use other base. Use ln. Then you think ln of left hand side equals ln of the right hand side. But then because the x it was in the exponent, you can now move in front because of the law of properties. So once you move it in front, you get x times ln of 2 equals ln of 7. How do you solve for x? Yeah, we can divide by ln of 2. You type that in your calculator. What do you get?
Why do they do ln instead of nl in its natural law?
Because it's log instead of l. So if they, I think people get used to see the l in front. So log is base 10, ln is the natural log. 1.348. Thank you. Hey, are you sure?
No. That's why I said it was a question.
Okay.
I think.
Check your parentheses. Check your parentheses. Do you get ln of 7 close parentheses
I know what it was.
and divided by ln of 2 close parentheses?
I didn't divide it.
Oh, you didn't divide it. Okay. So, everybody, what do you get?
That's 2.807.
Thank you. All right, good. So this is how you do it. Okay, everybody? Or if you think of different way, so if you think of like this way, instead of apply ln, we apply log base 2 on both sides. You get log base 2, 2 to the x equals log base 2 of 7, right? And then do you see what happened? Log 2 and 2, they are inverse function. So on the left hand side, you get x. On the right hand side, you get log 2, 7. But this is with base 2. We don't know how to compute base 2. So you want to use the change of base formula. That's why it's ln of 7 over ln of 2. You will get the same thing. Okay, so this is a different way to think about it. But my recommendation is apply ln. This is works in general. Because if you apply like other base, it depends on your problem. If your base is 2, you do the log 2. If your base is 10, you do the log 10. If the base is 5, you do the log 5. So this will change a lot. Okay? But if you use that method, apply ln is always ln. So it's a fixed method to get work for all the problems like that. Is that okay, everybody? So, yeah. All right, so this is 5.3. And, okay, so 5.4. So before we do 5.4, I want you to have some exercise. Okay. Here. About the condense and expand parts. So where is it? Okay. Okay, do this one. Take out another piece of paper. Condense the following into a single box with coefficient 1. Okay, so this problem is similar to the problem you know understand. Yes, it's the practice in there. Into a single box. Oh, this part, you have more expression. We want to combine into a single one. Okay? The part A is like this type. Part B right here is this type. Okay? So this is what you do. You move all coefficients to the exponents in the log. You want to first step. You want to move all the coefficients to the exponents. Oh, you have a log.
Oh.
Yes. Oh, no, no. Just leave it like that. Okay, let's see. We have 4 here. There's a 4 here. And 4 here. And then put the parentheses in the whole thing. Yeah, look at that.
It's not that bad.
Right, it's not that bad, right? How about you? Yes, and then combine them. Like here, we combine them. Because if the sign in front of it is positive, you put that factor in the numerator. If the sign in front of it is
Oh,
negative,
okay.
you put that factor
Good, positive,
in the
negative.
denominator.
Yeah. See, positive?
Yes, one of them are in the denominator.
Over there.
Don't factor it. You want to move on top. Yes. So, step 1, you move. Okay, so step 1, you move all the exponents. Move all the coefficients to the exponents inside the log, right? You move to the exponent inside the log, and then combine them. So when you see the sign in front of it is positive, then you put that factor in the numerator. If you see the sign in front of it is negative, you put that factor in the denominator. Okay, everybody? So that's why here, questions? Q to the 1/3? They're both correct. Both of you are correct. Yes. Okay. So first up, you move the 4 on top of here, move the 1/3 on top of here, move the 2 on top of here. Yeah, everybody? This problem has 6 points. If you do that, you get 3 points. Next, if you see the sign in front of it is positive, then you move that factor into the numerator. If you see the sign in front of it is negative, move that factor in the denominator. Okay, everybody? So this is another 3 points. So altogether is 6 points. Okay. So, and part B is going to be the opposite. When you have a single law, you want to expand to a sum or difference of simpler laws. Okay. So, yeah, this is a practice exam. You can work on those problems on your practice exam. Have a nice day. Don't forget to do the quiz today. Okay, and if you miss some assignment, please submit those as soon as possible. I know some of you never submit a single homework assignment. Please do that.
So if it's online,
Yes. Yes.
Okay.
Right. Good. Yes.
Oh, this is hard.
No, the 1/3 goes here. It's not the whole thing. Just that part. Just that part. Yes.
So even if this middle one was positive, this was negative, this would be the numerator and then this
Yes.
would be the okay.
So
it doesn't matter
as long as
if
it doesn't matter the order,
and
it's
then one
whichever is
positive,
positive.
negative.
Yes.
Okay.
Good.